Я думаю, вы заметили, это был непростой год для
I think you have noticed it was a difficult year for the Russian agriculture as well as the world agriculture. Not that the previous years were too favorable. Soil degradation, extreme natural phenomena, growth of cities, population, urbanization. The challenges facing the agribusiness is a litany. Now we're going to talk about how modern technologies, including AI, help us deal with these challenges. Today with us, founder and CEO of Cognitive Pilot, Olga Uskova. Very warm welcome. Hello. Great to be here. Leading researcher, Institute of Cytology and Genetics, Siberian branch of the Russian Academy of Sciences, Dmitrii Afonnikov. Hello. Founder of the Russian student startup, DairyVision, Maxim Izmesiev. Maxim, thank you. Olga, shall I start with you? Perhaps one of the main proselytizers of AI. Perhaps one of the main popularizers of AI. Not just a popularizer, one of the implementers. We actually built the plant. Well, I am continuing. I'm just giving you the credit roll. Well, in agribusiness, in agro, and it's a general question to all the panelists. If you want to answer, feel free. The influence of AI on agricultural sector. What has it been? What have we been able to implement? What tasks have we been able to solve? Well, let me start from the very beginning, from the summary that you gave at the outset. Agro is always a disaster zone. If you go back over the 1,000 years to Egypt, either locusts or something else there was always some kind of a plague. There's three groups of factors at play in the agro industry: humans, the Lord Almighty, and now it's the robots. And the more robots there are, and the more predictable and realizable the economy of the agribusiness is. I would like you to get that video rolling so we can actually show some proof. What we're showing is today. It's not pilot projects. It's the robots actually working in the fields for money. What we are saying is that the procedure has essentially changed. The procedure, the routine of working on the ground. People are being taken out of the lineup of production factors. The toolkits are becoming very accurate, very precise. Accuracy up to several millimeters. The ability to, till a field in any weather, in any time of day. You can work in swarms, commanded by one dispatcher. You can automate not just at the level of one district or one country. You can automate on the level of the globe. You can see this feed from the dispatch room that takes the feeds from all the robots. The most important thing is that this is the working thing. I'm not talking a pilot project here, not just 5 machines having fun. It's the actual economics. This is actually acceptable for operation en masse in agricultural business. And the factory was built in Tomsk, the radio electronics factory, radars, microelectronics. We actually were able to deploy, to manufacture the entire lineup of components. We're going to come up with this question when we see this point at the video. It looks like humans can be taken out of the equation at all. Let's freeze this robot for a while. This is the peak of the current story, where it is a fully autonomous baby. We made it this small for a reason. You can put it into the back of a truck, and you can hook up all the implements to it. And thanks to the presence of this element, you can code an army of these robots with very precise tasks, sowing all the way to cultivation, recultivation. Then you use the soil analyzers, the weather analyzers that give management to the growth of plants. And the whole thing is supporting a process that I would call this. In 2009, there was a very important revolution that we failed to notice, actually. Let's show the second slide. In 2009, the strength of urban population exceeded the strength of rural populations. What this means is that people who want to eat are increasingly numerous versus the people that manufacture the things to eat. And this was a revolution. This is the chart that produced the revolution that we are trying to sort out in the direction that is entirely correct for both the world and Russia. You know, we are trying to become the breadbasket for the world because we've got the necessary arable lands and we've got the robots to till them. And we've got the goodwill to feed ourselves and everyone around us. And then we've got the water, the fertilizers, the purist, and the humans. We've got all of that. I've got a whole string of questions as an economist, but Dmitrii, to you. You are about selection, genetics. I think genetics, one of the main beneficiaries from AI. What are the areas that you are seeing, the areas of promise? What does the Russian Academy of Sciences see going forward? Well, precision farming is indeed highly useful precision farming. Maybe we can call it more smart farming, but all the manipulations are done at the right time, in the right place, with the right effect, you know, to minimize the effort and get more benefit. It used to be, you know, perceived as being about observation of fields, you know, data collection and monitoring, decision-making, and then certain actions, agronomic measures as per certain recommendations. There's an increasing understanding that an increasing role is played by the plants. You know, it takes a lot of understanding of what you need to sow for it all to grow, what plants will actually grow if you seed them. And the role of selection here, the role of breeding here is rather high. You know, planning the varieties and lineups that would be suitable for the certain ecological conditions, that's hugely important. And this is the goal of genetics and breeding, of selection. There's no task to create a universally resilient species, resilient to any stress conditions. It's about finding the right varieties suitable to specific environments that will give the best yields with the best resilience, and perhaps do some genetic editing so that we give better performance in certain environments.
And to adapt them based on the changes. Yes, absolutely. Based on the environment, based on having the full knowledge of what kind of agricultural conditions we're talking about, what kind of precipitation we have, temperature during the year. AI helps to solve all these tasks. Maxim, coming back to Olga's words regarding the fact that there are indeed more people who just consume groceries, who want to eat, so to speak, than people who are producing this food, cultivating it. So you originally wanted to become a robotic expert, specifically in agriculture. Where did this desire come from? Because, you know, we're talking about how the technological changes shift the way we live. But young people do not want to work in the countryside, really, because the salary is not that high. That's true. Everything has changed. The level of salary increased, and the person does not come to work with a shovel in the countryside, but, you know, like an Interstellar, There's quite a lot of 25, 30-year-olds in the countryside right now. But Maxim, where did this idea come from? Because you work with cattle, really. Tell us about your project. What problems do you manage to solve? I mean, I know that you have passed a SBIR accelerator. You became one of the finalists. So, based on your startup, what is the economic effect? Expand on that, please. I'll start from this beginning, when you asked about robotics. It sounds like some cyberpunk. Robotics for agriculture sounded like that for me, so it was very exciting to try that out, to do something with my hands, you know. So the automation really got into me, you know. In agriculture, there's crop production, livestock farming, and the HR-related problems, and we are solving this problem with our project. So, can you imagine a farm with thousands of cows, and it's like as if we have a farmer that follows each cow and monitors it 24/7. And this is what computer vision does. This is what our product delivers. If we talk about numbers, on the farms where we have been piloting, we're talking about 94% accuracy compared to the current technology. In addition to that, we cover 1/3 more herds than previous technologies because we have an exterior assessment, the gait assessment, the fatness of the cows assessment, and many other things that are tied to the external indicators of the animals. So we're talking about health. What are the effects? Yeah, we're talking about the health of the livestock, the physiological, reproductive performance, and it's important that the cow on the farm should be this machine that produces raw material, which is milk. And during the project, we understood that the highest profitability of this quote-unquote machine is achieved on the 5th year of lactation. But on the farms, cows live somewhere around 2-3 years, although in nature they can live up to 20 years. But it's not profitable to do that. It's more profitable to replace the livestock. But we aim to maximize the profitability of the animal by eliminating the diseases at the earliest stage, when it's still profitable to treat them, to treat the livestock. Olga, coming back to your words, I'm very happy that we have moved from the pilot to the production. It's great that it's working. What are the economic effects of the implementing such projects? Now, you have shown this cute little machine. Is it okay for farms? Like, can they afford that? Like a medium-sized farms? Well, it's absolutely possible. Economic story is here, and the farmers can use that. And that it works directly on the land. It's there are actuators that can control the device, and farmers know how to save. When you work on the field, it's like you play with nature, with God in a way. And it's one of the most critical target groups, and one of the most, stingy in a way, people, because people start to with a teary face talk about hurricanes and all other weather conditions. But anyway, the numbers are important because there's money behind it, and the transition to robotization should be ensured that you reverse the situation in 1 or 2 seasons. Otherwise, you won't be able to scale that. It depends on the volume of the farm, obviously, and the investments. There are 2 effects. There's robotization of existing farms. That's 47%. That's the immediate effect, thanks by changing the work time. An agricultural person who works on processes gets tired and loses attention. So this solution helps to reduce the risks and increase efficiency. Other more detailed indicators are here, like fuel economy, the grain material savings, the fertilizers, and so on and so forth. All in together, the effect is almost 100%. And that testifies to the fact that launching such systems in one season gives a fundamentally new economic shift. And next you have other most popular questions. I mean, like, where do people go? They will be replaced, right? Everyone will be robotized, right? Well, it's not that I've prepared this question, because everyone are very tired of answering these questions. Because you understand the answer, right? So we have to skip that. We can skip that, right? We'll definitely get into that. But Dmitrii, going back to precision farming and, talking about the breeding, one of our main problems, it might not be so critical, and these are seeds. We talked about this like a decade ago, 2 decades ago, like after 2014, when our agriculture sector literally took off, and we're continuing to talk about that now. What is being done here? How AI helps? We're talking about extreme climatic conditions. It was a very challenging year for Russian farmers. I mean, it was better at some regions, but some regions experienced droughts. Some, on the other hand, had snow in May or flooding. There's more emphasis on extremely hardy varieties of seeds, or just refine the expansion of the range of domestic seeds. I think there's no point in focusing on any specific varieties here. It makes sense to focus on technologies that can solve certain problems. If we implement these technologies, we can make any varieties for any conditions. And this is where AI really makes a big difference to the overall solution. Because on the one hand, for breeders and geneticists, it's very important to understand the characteristics of the plant. And it needs to be done on a mass scale so that we can compare mutations and the resulting phenotype. In this sense, AI helps, firstly, to determine the characteristics of plants based on image analysis. We're talking about the size of the fruit, the leaves of the plant, diseases. Now, that's the first part. Secondly, when we know the genome that has been read or its variability, we can match its variability of that genome. And here too AI is actively used, and it allows us to take into account not only plants in lab conditions, but also how the environment will influence that, and fertilizers, and what are the soil characteristics. Such projects are now actively being developed, and AI is actively used to resolve these tasks. In fact, knowing the mutations, we can predict what kind of plant will we have. On the other hand, if we want a plant with some specific properties, we can guess what mutations we have and what genes we should make and how to get such a plant. Experimentally, in science, these tasks are resolved, so it is shown to be possible. So I think this problem, okay, now the problem is to accumulate more data so that we can solve the tasks and problems with AI. Yeah, the volume of information, the quality of the databases, quite a lot of work has been done that is gradual and planned, yes, and targeted. Maxim, but many experts in AI often say that using neural networks and ML usually leads to quite unexpected results, because different models have a different perspective of the problem, perspective, quote unquote. But when you implemented your product, did you have any surprising results? Have you managed to find a new problem, or on the contrary, establish some ways to solve the existing one? Were there any surprises? Well, as I have said, when we found out that the maximum profitability of cows occurs in the 5th year of lactation, we started to target on that. We had pivoted. We were aiming first at the software that would process data and then interpret it for the farmer or the person who works with this app that we were developing. And then we realized that the problem was the collection of data, the analysis of the herd, the analysis of the farm, and this is where we started to focus on. Just a human question. I know a couple of industries, but I would like to ask about the inter-industry cooperation. I've seen that ESG Alliance on AI have drafted the first journal of cases. It's called AI Good for Russia. I will definitely look into that. I haven't seen it yet. They collected AI solutions for working with environmental and social challenges. This casebook is translated into English and it's available in Russian. Now, how relevant is it? I'm driving at the following. I talked with experts in AI and other industries, and they somehow discovered their passion, or they discovered each other. They communicate with each other now. They found each other by accident, though. But, the overall question, how do you ensure interaction between developers and those who are the clients, who set the tasks, like between a farm and a cognitive pilot? I know you work proactively, but there are small startups that do not yet have this experience. How do you transfer technologies between each other? Well, let's divide this question into two. The first issue is reports and other things. The industry is just being informed that it's a cross-cutting industry. Obviously, when an industry is being formed, it's usually the investors and financial players who enter there, because now the benefits are counted, are like hundreds of percent, the margin, And financial players, obviously, they need to have some reports, they need to have some expert opinion to see, to look at the players and to understand their positions. And so this a so-called, professional community that supports these financial players, and it helps to have financial players to navigate through all of that, and that's especially relevant for early stages. The other part is real life, and this is where the things are happening now, and that's important because according to old rules, everything had to be long, and it took a long time to build alliances. Now they're quite quick in building and in being gathered, because we cannot afford this long period of alliance formation. If someone comes to us with a report, we send them to some part of the ecosystem. If they have a prototype, we start to test drive it on our pilot customers, and these people are then entering the market quite quickly. This is the independent level of independence we're talking about, and we now have present and the future combined together, because people are trying to work on the success stories that you can actually test drive in real life. I would like to support Olga here, because agricultural workers are not only thrifty, but they are also conservative. And it takes quite a lot of effort to convince them of something, because they do not trust you. It's very hard to really put them into the perspective of liking the new technologies. Well, indeed, people know the price of a mistake, the price of risk, and, given the situation, the cost of finance and HR-related problems, I think this process will go faster. Now, using AI in the fields maybe will kill off some of the professions, some of the jobs. Maybe we can have some top 3 jobs in agriculture that will appear in the near future. Maybe some of them will become obsolete. Maybe we should give some food for thought for some people to think about their future job. The salaries are rising in agriculture, so maybe it's a promising field. But Dmitrii, what will happen in genetics, in breeding, fertilizers? What will happen in the context of talent? If we talk about genetics and the breeding, I think there will be some high-tech jobs not in some individual farms, but in breeding centers. These specialists will work with the modern genetics technologies. They will be able to apply state-of-the-art technologies for creating new varieties, and that's obviously a very promising topic. There's a lot of interest in this now. These centers will also have experts in analyzing biological data so that we can resolve these problems in a targeted way. But these are the people working at the borderline of biology and agrotechnology, agronomy and data analysis. And it's very hard to train people like that, but I think that these experts will be the most valuable ones. Well, yeah, the intersection of different competencies is probably going to be the most valuable in the future, job-wise. 3 experts in agriculture, the most promising one, Olga. Well, neural engineers, neural network engineers, trainers, ML experts, dispatchers, drone operators, drone operators. And it might sound weird, but task setters, those who set tasks for AI, because I don't know how it will be called, neural philosopher or agronomer, neural architect, neural trainer, teacher. I don't know how it will be called. Depends on those who will enter the market first. But this is key right now. You have to integrate all these technologies in the agricultural process. These financial benefits, the more efficiently you implement them into your processes, the more efficient you are. So it's like you are an architect of your business. Yes, the economic architecture, the architecture of the business. Yeah, I'll continue on the analytics. Agro-data analysts or agro-data analytical experts, I don't know how you're going to call that, but this is a person who understands the subject area and also is good in analytics and IT, and maybe some kind of a consultant who has hybrid knowledge in all sectors of agriculture. He's like a resource consultant. He optimizes resources in the enterprises. That's an interesting approach. Right. And in conclusion, we prepared a small interactive quiz for you. There are 3 different news from the agro-technology world on the screen right now. Olga said that we're at the point where the future and the present are kind of mixed and combined, and like even the past is mixed here as well. So it's hard to understand where the truth is. So the first case study, the farms and the cows are wearing VR glasses that show green fields, and thanks to the VR sessions, the cows' anxiety levels decrease and milk production increases. So do you think it's true or false, Dmitrii? I think I will try that, but I don't think it's likely that it can work, and that anyone tried it. I don't think it's a scalable solution. I think it's false, Cows have different color understanding and separation, so they see differently. Yeah, but maybe we should put headphones on the cows and put some Beethoven symphony. I've seen an image like that. They tried it, but it didn't work. Absolutely right, Maxim. You are right. It has been tried in Moscow region. Well, there are many weird people around, And the cow said it felt better, yeah. Wagged its tail, right? Yeah. In the approval. The next case, a Spanish company has created a robot to automatically pick strawberry with 24 robotic arms. Well, that's interesting. Picking berries. I think it might happen. I do not know about the number of hands. Why does it need 24 robotic arms? It's even kind of romantic, Well, it's like open source data that we use published on the internet. Well, maybe it had 28 hands. Yes or no? So yeah, okay. Let's say it's true. I think it's true, but either it had. I think there is a catch. Maybe fewer or more hands, or maybe there was strawberries instead of something else. Right. The correct answer, it was true. And the final question is related to a major challenge, by the way, of the entire ecosystem. Sometimes the bees die unexpectedly, and in Singapore, for the first time, they introduced robotic bees. Do you think it's true or false? I don't think that there is a system like that. Bees impact in agriculture in a major way, so it's a big challenge. Yes, but I don't think it's true, because pollinating plants is a very delicate process, very delicate procedure. So I think robots will have a hard time doing that. So the answer is false. Yes. Maybe at some point in time we will be able to achieve that, but it would be great that the challenge related to bees would be resolved by normalizing the environment so that bees reproduce in larger numbers. Anyway, thank you very much for this dialogue. It was a very instructive and exciting conversation. Now we'll talk about health. And we'll talk about the fraudsters and how they use AI, well, deepfakes and other things. And obviously, we're not only going to talk about the bullet, but about the armor to protect us from it, and how AI can be used by fraudsters and those who protect us from them.